Kepler's law of harmonies, also known as Kepler's third law. Johannes Kepler was born in 1571. He was one of the most important guys to develop the theoretical construction of astronomy. Kepler began his astronomical journey when he became the assistant of the premier astronomer of the time, Tycho Brahe. Brahe soon realized how intelligent Kepler was and gave him an extremely hard task of understanding Mars, so that Brahe would have more time to work on the solar system. Ironically, it was this understanding of Mars that led Kepler to be one of the best astronomers of his time, surpassing the knowledge of Brahe. Kepler's third law states that the square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. This can be illustrated when you look at the solar system. Planets closer to the Sun have a much smaller semi-major axis of orbit, and they thus take a smaller time to orbit the Sun. A bigger orbit is equal to a longer period to orbit the Sun. Mathematically, we can look at his law like this. The time in years that it takes to orbit the Sun can be equal to the astronomical units, also known as AU, cubed of the distance from the planet to the Sun. We can look at it like T equals R to the 2/3 power, or R equals T to the 2/3 power. For example, Mars takes 1.88 Earth years to orbit the Sun. Instead of using T in this equation, we can also use P. We can find the astronomical units of the distance from Mars to the Sun by doing 1.88 to the 2/3 power. We thus find out that the length of Mars' semi-major orbit is 1.52 astronomical units. Pluto's average separation from the Sun is 39.44 astronomical units. We can find Pluto's orbital period by doing 39.44 to the 3/2 power. Doing this calculation, we find that it takes Pluto 248 years to orbit the Sun. So, the larger a planet's radius of orbit, the longer it takes to orbit the Sun. The end.